Now, what we previously did, we previously learned what is hashing, what is encoding, what is encryption. Now let's learn about symmetric and asymmetric encryption. So let's see. So what is encryption? So it is the process of converting a readable data into text which is difficult to understand. So let's suppose you have a text, you want to encrypt this. So what you will do, you will encrypt this using any encryption algo, and you will get the another gibberish text, x, y, z, anything, and this text is known as ciphertext. And you can also reverse this text to original text if you have the keys. So what is key? So let's see what is key. It make use of cryptographic key. Yes, in encryption, what you have to do, you have a plain text that you want to encrypt, and you must also have key to encrypt this. So in encryption, we use key to encrypt this plain text, and we also use this key to decrypt this plain text. So the key is depend upon the encryption type that you are using. If you are using asymmetric encryption, then you have to maintain only one key. If you are using asymmetric encryption, then you have to maintain two key, one for encryption, one for decryption. And symmetric encryption, single key used for decryption and encryption. Okay. So cryptography considered as a mathematical value which encrypts the encryption method used to convert the readable data into unreadable format. Yes, encryption use key to encrypt the readable text into unreadable text, that is known as cipher. Now let's see what are the some advantages and yes, why do we encrypt data? So we encrypt the data for protect confidentiality. That means if client 1 is sending data to a server, how will server know that the data that is coming from client 1, or you can say is this data is being tampered or not? Yes. So that's why we use encryption. We encrypt the data we send to server 1. Now when the server 1 will decrypt the data, he will know the data is not tampered and it is coming from client 1. Now the second is prevent unauthorized access. Yes. And the third is secure communication over a network. Yes. Now encryption. So let's I'm sending this data to server 1. Okay. Now if someone takes it, let's say a hacker take this data, and he want to see what is, because when he takes the data, he will get the ciphertext, and from that ciphertext he cannot be able to get the original text back because he didn't have keys, and if he has key he can get the original text back. Okay. So let's see what is the flow. The flow is, we have a plain text, then we have a key. So with the plain text and key, we will encrypt the our plain text with the encryption algo, then we will get the ciphertext, and from the ciphertext plus keys we will decrypt this by decryption algo, and then we will get the original text back. Okay, this is the general flow of encryption and decryption. Now encryption is of two types, the symmetric encryption and then we have asymmetric encryption. Now let's see what are the disadvantage and advantage of what symmetric and asymmetric encryption is. So first of all, symmetric encryption, same key is used for both encryption and decryption. That means, now let's suppose I have client 1 and server 1. Now I want to send any text, this text. Okay. Now so because this I'm using symmetric encryption, I need to use same key. Let's say my key is 1 here. Key is 1 here. So now when I send this, when I encrypt this will become a ciphertext, any unreadable text. Now what I will do, I will send this text to S1. Now if the S1 have key 1, the same key, the key is 1 here and the key is 1 here, now he can able to he will receive the ciphertext. Now from this key and from this ciphertext, he with the decryption algo he will get the original text back. Now yes, so it uses same key used for both encryption and decryption. Okay, the same key is used here. Now let's see some algos of symmetric encryption. We have DES. In the DES we have fixed key length. I guess it is 56 or 58. I'm not confirmed, but the length is very small here. Then it process data in 64-bit blocks. So what these encryption algo will do, so they will divide our data into bits and process that data into some bits. So DES divide our data into 64-bit blocks and then process it. So it performs 16 round in encryption process. So it performs 16 round. DES performs 16 round. So what is round? So what these encryption algorithm will do, they don't have a really big step. They have a repeatable small step, like let's say mix bytes, shift rows. So let's say this is the repeatable step. What they will do, they will repeat this step multiple times, and this repeatable step is called rounds. Okay, so DES performs 16 rounds in encryption process. Then it is considered insecure today due to a small key length. Yes, because the key length is small, it can be broken easily as compared to other advanced encryption algorithm like AES or Symmetric or RSA. Okay, now let's see what is AES, Advanced Encryption Standard. So it is recommended. So here we have the key length of 128. We can also use 192 bits. We can also use 256 key length. It's supported here. Okay, it processes data in 128 bits block. Again, here the processing bit blocks is higher as compared to DES. Now the round depends on the key length. If the key length is 128, the round is 10. If the key length is 192, the round is 12. If the key length is 256, the round is 14. Okay, now let's see what are the advantages of symmetric encryption. Faster than asymmetric encryption. So it is faster than asymmetric encryption, other encryption that we have. Okay, the second point is required less computation. Yes, it required less computation, and that's why it is faster also. Now the third point is best for encryption of bulk data. Yes, so the real time or messaging application, they have many data, so you can use AES to decrypt this bulk data over a network. Okay, and let's say you have a file and you want to save this file into a disk. So what here also AES is used. So you have a file, you will decrypt this using AES, then that text will be, or that file that AES will spit out will be stored in the disk. So that in this way your file is also very secured. Okay, now the fourth point is efficient for storage and real-time communication. Yes, in the real-time data we have many data, and we want to do encryption and decryption faster. That's why we use symmetric encryption. Okay, now let's see what are the disadvantages of symmetric encryption. The first disadvantage is key distribution problem. Yes, here so now let's take an example. We have a client 1 and then we have client 2. Now client 1 want to send some data over a network to client 2, and also client 2 want to send some data over a network to client 1. Now let's say client 1 have a data, this data he want to send to client 2. Now because we are using symmetric encryption, we have only one key, so we somehow need to let no other party that hey, key is 1. If he didn't know the what is the key, then he will not be able to decrypt this data. So here this is the problem here, key distribution problem. Difficult to securely share secret key between the clients. Yes, exactly this. Now the second thing is scalability issue. As the number of client increases, the server must manage more symmetric keys, securely distributing them. So let's understand this example. So let's say after some time we have many clients in our application, or you can say microservices, client 1, 2, client 3, client 4. Now we have only one server. Okay, now this server, when talking with client 1, he and when talking with client 1, he needs to know what is the key of client 1. So it needs to maintain a map like client 1 key is 1. So let's suppose here key is 1, here key is 2, here key is 3, here key is 4. So it somehow needs to know what is the key that client 2 have. So it needs to store the mapping of client versus key. Client 3 have keys, client 4 have this key 4. So this is the also problem here. Okay, so yes, now let's see what is the asymmetric encryption. In asymmetric encryption, it uses two different key, public key and private key. So public key used by sender to encrypt data. Yes, when sender sending the data, it will encrypt the data using public key, and what is private key used by receiver to decrypt data. Let's see this by example. Let's say we have a client and we have a server. Now what this server will do, this server will generate two keys, private key and public key. Now as the name suggests, this will distribute this public key to client. Now let's say a hacker is also listening to this network. The hacker also have the public key of server, hacker also have the public key, and this client that is sending data also have the public key. Now what client will do, client will, let's say the client the data that is sending xyz, what client will do, client will decrypt this data, encrypt this data using this public key and send it over a network. Now this data come also here, and then let's say this data come also here. Now because only server have the private key, so he can see the data, because if this data is decrypted by its public key, here the client itself cannot see this you can say cipher, cannot decrypt this data, because client also didn't have the private key. Only server can decrypt the data, because only the server have the private key. Okay, so that is the concept of private and public key. Now we have encryption and key exchange algo. So RSA, it uses 2048 bytes. Here the key length is 2048 bytes. Okay, then we have DSA, then we have Diffie-Hellman. So Diffie-Hellman is used as a key exchange protocol that under the hood uses private and public key. Okay, then we have ECDHE. So these are some algorithm that that use asymmetric encryption. Okay, now let's see what is the disadvantage of asymmetric encryption. No key distribution problem. Yes, because so what is the problem in symmetric encryption? The key, both the server, client 1 server, key is 1, and in the symmetric encryption this server also needs to know what is the key. So here the key distribution problem in the symmetric encryption. In a asymmetric encryption, as we can say, we have two keys, private key and public key. We will send this public key to anyone, and anyone can, or client, anyone can encrypt the data using this public key, and because only server have the private key, he can only see the data. Okay, so advantage is no key distribution problem. Each user keeps their private and public key secret. Okay, yes, so as you can see, the server keeps their private key secret. Now let's come to second point. Enable secure key exchange protocol like Diffie-Hellman. Yes, Diffie-Hellman under the hood use asymmetric encryption. Okay, so we have ECDHE also. Now let's come to third point. Support digital signature authentication integrity verification. Okay, so what is this? Let's say this client want to send some data to server. Now how the client will know the data that is coming? It first he has two questions: the data that is coming from is coming from client one, or the data that has come is not tampered, not, you can say, modified by someone or by some hacker that is listening over this network. So asymmetric encryption also solve this problem. We will see this problem in depth after some time, or in the next video. Now let's see what is the disadvantage of asymmetric encryption. The first disadvantage is computationally expensive. Yes, here the key length is also very high, so it is also very computationally expensive. And second thing is, second, slower than symmetric encryption. So it is slower than symmetric encryption. Now the third thing is not suitable for large data. Yes, because it is slower, it is not a very sensible decision or trade-off to use this encryption for a large data in the real world. So let me tell you one thing: in the real world we will use hybrid encryption. So what is hybrid encryption? It uses both two things: symmetric also and asymmetric also. Like, let's take an example: https use both. Then you have ssh. So first asymmetric encryption is used for authentication, and for authentication, okay, and a key exchange. When the single key is exchanged between the client 1 and client 2, then it uses symmetric encryption to decrypt and encrypt the data. And in the first go and in first it will use asymmetric encryption uh, to exchange a single key, or you can say same key, because symmetric encryption needs to have same key on the both side. So it uses asymmetric encryption for exchanging this key exchanging this key between these two clients. And then after, because they have one key, and also asymmetric, a hacker didn't know this key. Because of asymmetric encryption, now only these two clients have this key. Now with the use of symmetric encryption, this data will be encrypted very securely. Okay.
Now let's see how digital signature work, and let's see what problem digital signature solves. So let's say we have client one and then we have server one. Now this client sends some data. How does this server will know the data is coming from this client? This is the first question that the digital signature help us to solve. And the second question, how do I know the data that is getting to server 2 is not being tampered in between? Suppose a hacker change this data and send back to server 1. How do server 1 will know this data is not getting tampered? Okay. And the third thing is, if the data is coming from client 1, so this is called a non-repudiation. If the data is coming from client 1, now after after let's say, when we understand this, when this data is verified by server 1, now server 1 can say this data is coming from client 1, and client 1 cannot deny this. So this is called non-repudiation. Okay. So digital signature authentication, it is used for authentication who sent it, integrity, message not modified. The third thing is non-repudiation, that we have just seen, sender cannot deny. Okay. Now let's see how digital signature works. So let's take an example here. So client generates public, first step is client generates public key, private key. Now this is client and this is server. So it will generate its public key and private key. It will send this public key to this server. Now the server have the its client public key, client one public key. Now the second step is client hashes the payload. Let's say we this is the payload I want to send. The payload is, you can say, payload, or you can say it's a message. The
Now let's see how digital signature work, or even first let's see what are the problem that a digital signature will solve. Now now okay now let's say we have a client one and this is server one. Now server one sends some data to sorry, client one sends some data to server one. Now server one will get this data. How server will know that this data is coming from client one? Okay, this is the first thing. And the second thing, how server will know the data that I'm getting is not modified. The data is not modified. Okay. Now for these things, digital signature comes into the picture, and this solves the both these two problem, and also one problem that if a server once gets that data from client one, after some time client one say, hey, I have not sent you data. So this is called repudiation, non-repudiation. Digital signature solves three problem: authentication, that who is sending the data, who send it; integration, if data is modified, that means you cannot modify the data; and the third thing is non-repudiation. Sender cannot deny, the sender cannot deny that I have not sent you the data. Now let's see how this digital signature work. Okay, the first step is, now let's say we have client one and then we have server one. The client one will generate two things: private key, its private key, and its public key. And also in digital signature we encrypt the data by private key and decrypt the data by public key. Whereas normally, as we have seen, that we decrypt the data, we encrypt the data using public key and decrypt the data into with private key. But in digital signature we encrypt the data in with public key and decrypt the data using encrypt the data using private key and decrypt the data using public key. Okay, let's see the first step. The server has created two things: its private key and its public key. It will send this public key to this client. So now client know, server will know, this is the server will know the public key of client. Okay, now let's say I want to send the data abc to this server one. Okay, so what I will do, I will first generate the hash, and the hash will be, let's say the hash will be 10 10 and 10. First I will create the hash of my payload, the data I am sending, abc hash 1010. Okay, and then what I will do, I will encrypt this hash using my private key, and the data, let's say encrypt, I encrypt this hash using my private key. The data I'm getting, I will call it as a signature. So this is the signature. Okay, now what are the things I have? I have signature, I have this hash value, I have a client public key, I have a client private key, sorry, I have client public key. Now what I will do, I have a message. I will send these two things: signature, that is coming from encryption of hash value, hash is coming from the message. Okay, so we will send two things: the signature and the normal payload. With for this example I am not encrypting this payload, so what we will send, signature, I'm writing is as sign, and a payload. Okay, now I will send this to client server one. Now server one will receive this message. Now server one, but it will do, it will, now server will one server have the public key of the client. What it will do, it will decrypt the signature with client public key, with the client public key. Okay, and what it will get back. So what we have encrypted, we have encrypted the hash, we will get back the hash. Okay, this is the first step. And the second step, server also get the payload, this abc. Server, what server will do, server will hash this abc, this payload you can say, and it will guess the computed hash. Now we have two hash. The first hash is coming from decryption of the signature, and the second hash is coming from hashing of the payload. Now what we will do, we will compare these two hash. If this hash, computed hash, it is equal to our hash value that we have get from the decryption of a signature. If this condition is true, then we are sure that this value, this that data is coming from client 1 and not tampered. And now how, and if if this is not true, that means data is tampered. So this is under the hood how digital signature works. You will see, like in JWT you can see the payload. Okay, now the question is, how, if you change the payload, then server will not accept it. Why? Because let's take the example. In between, hacker changed this value to xyz, our payload, that is abc originally, that hacker changed this value to xyz. Now the server, in the server, the sign we have, what we have get, we have sign, and then we get xyz. Now when we compute the hash, first what we will do, we will decrypt this, and we will decrypt this, then we get the hash value, original hash value that the client have generated, original hash value. Okay, now when you hash this xyz, you will get the different hash. Why? Because you have tempered the data. Okay, now because you have tempered the data, you will not, this condition will not match. And if this condition is not matched, that's how server will detect data is tempered. Okay, yes. Now let's see, we have solved the three problem authentication, how authentication problem is solved. Because now if I am not able to decrypt this signature, if I am able to decrypt this, so if I able to decrypt the signature with the public key, that means you are client 1, because I have the public key of client 1. That means this data is definitely encrypted by client 1 private key. Okay, this prove two things. The first thing is authentication, and the second thing is non-repudiation. That means now client 1 cannot say, hey, I have not sent you that data. Because why? Because now this data is decrypted by public key of the client 1. Now client 1 will not say, hey, I have not sent you data. Okay, now the second thing is integrity. That's what we have seen there, that like if you change the data, if you change the payload, the sign, the payload that is in sign will not match this. And this is how digital signature works. Okay, thank you. If you have any questions, so let me know.